Take two identical cups, fill one with cold water, fill the other with hot water. Put them in a freezer at the same time. Which one freezes first? Your instinct says cold. Obviously cold. Cold water is already closer to freezing. It has less work to do. That's just logic. But here is the thing. In a lot of conditions, the hot water wins. Hot water freezes faster. And nobody fully understands why. This phenomenon has a name, the Mpemba Effect, named after a Tanzanian student called Mpemba, who noticed something strange in 1963 whilst making ice cream. His class was making ice cream mix. The rule was, let the mix cool before putting it in a freezer. But Mpemba was running late. He put his hot mix straight in and his ice cream set first. His teacher told him he was wrong. His classmates laughed. But Mpemba kept asking the question. Eventually, he got the attention of a physicist named Dennis Osborne, who came to his school, heard him out, and decided to actually test it. They published their findings in 1969. The scientific establishment did not take it well, because here was a schoolboy from Tanzania telling physicists that they had missed something obvious about one of the most studied substances on Earth, water. So why does it happen? Here is a frustrating and fascinating answer. Scientists have proposed at least 5 serious explanations, and none of them has fully won the argument. When you put hot water in the freezer, some of it evaporates immediately. Less water means less mass to freeze. Less mass freezes faster. Simple. But experiments have been run in sealed containers where evaporation is impossible. The effect still appears. So evaporation alone can't be the full story. Cold water holds more dissolved gases, like oxygen and carbon dioxide, than hot water does. When water heats up, those gases escape. Some scientists believe these dissolved gases change how water behaves when it freezes, slowing down the process. Hot water, already having lost its gases, freezes more cleanly. Interesting, but again not proven to be the primary cause on its own. Hot water creates strong convection currents inside the container. Warm water rising, cold water sinking, constantly circulating. This movement actually helps hot water lose heat faster than cold water sitting quietly in the container. Think of it like this. Blowing on hot soup cools it faster than letting it sit. The movement matters. Here's one that surprises people. Hot water can melt the frost on the freezer shelf beneath it. That frost acts as an insulator. Remove the frost and the hot container now has better thermal contact with the shelf. Better contact means faster heat transfer, which means faster freezing. This is highly dependent on your specific freezer, which is part of why this effect is so hard to reproduce consistently. In 2013, a team from Nanyang Technology University in Singapore proposed something more fundamental. Water molecules connect to each other through hydrogen bonds. When water is cold, these bonds are under tension, like a straight spring storing energy. When water heats up, the molecules spread apart, releasing that tension. The bonds relax. When the water then cools again, those relaxed bonds release more energy. And the researchers argued this is what speeds up the freezing process. It's controversial. It's still being debated. Mpemba effect depends on so many variables: the shape of the container, the type of freezer, the minerals in the water, the exact temperature used, and many others. Different experiments produce different results. Some labs reproduce the effect easily, some cannot produce it at all. That's not a failure of science. That's science working exactly as it should, sitting with uncertainty, running more experiments, refusing to pretend we know more than we do. You can try this yourself right now at home. Take two identical cups or containers. This is important. The containers or cups must be identical. Fill one with cold water and fill the other with hot water. Note the exact temperature if you have a thermometer. Put them on the same shelf in your freezer at the same time. Check every 15 minutes. Does the hot water freeze fast? Maybe, maybe not. The honest answer is it depends on your specific freezer and other conditions.